As the worldwide demand for raw materials grows, faster turnarounds and an increase in terminal throughput have become commonplace. More than ever, seafarers working aboard bulk carriers need to rely on their training and professionalism in order to deal with these pressures whilst remaining safe when working. Before any crew member starts working on a vessel, they'll undergo a familiarization program to become aware of the working practices and safety procedures. Safety, however, does not stop there. The sheer size of a large bulk carrier can give the impression of great strength. But that strength can be severely weakened by unseen forces. Forces powerful enough to endanger the ship and its crew. So safety aboard a bulk carrier also depends on an understanding of the vessel itself and the effect that these forces have on the ship's structure. And if the vessel is handled with care, then the vessel will care for its crew. During the 80s and 90s, there were a considerable number of bulk carrier losses. In some instances, there was enough time for the crew to abandon ship. But in many cases, vessels sank with little or no warning. A number of these losses were attributed to structural damage, leading to catastrophic failure. After these incidents, both the International Maritime Organization and the International Association of Classification Societies carried out major research into many of the known and suspected structural failures among bulk carriers. The knowledge gained has led to ongoing improvements in vessel construction and inspection, along with new technology that enhances operational safety. For example, under the International Convention for the Safety of Life at Sea, SOLAS, a specified safe means of access for survey and inspection is now a mandatory requirement. This aids the early detection of structural defects. And specialized training for port state control inspectors means independent inspection of a vessel's structure is more stringent than ever. The installation of high-level water alarms and monitoring systems in cargo holds, ballast tanks, and dry spaces forward of the collision bulkhead is also a mandatory requirement. High-level alarms and water ingress detection systems, commonly known as WIDSs, quickly alert watchkeepers to potential flooding. These allow ship's personnel to initiate an appropriate response in good time. Further requirements include immersion suits to be carried on all ships. And since 2006, the provision of free-fall lifeboats to be fitted on all new bulk carriers. But despite these improvements in design, condition monitoring, and safety equipment, bulk carrier crews still need to manage and be aware of the operational risks. Any bulk carrier can be vulnerable to catastrophic failure if not operated within its design limits, or if structural fatigue and damage is ignored. And a ship whose structure fails can be lost in a matter of minutes, as the resulting ingress of water could quickly lead to irreversible flooding. The speed with which a bulk carrier and its cargo can sink should not be underestimated. This highlights the necessity of water ingress detection systems. But of course, the most effective safety measure will always be the prevention of structural failure in the first place. The causes of structural failure, instability, or sudden water ingress are not necessarily due to poor design. In fact, the overall safety of a bulk carrier often depends on the degree of care taken by ship's crew and shore personnel during loading and discharge. Structural failures and instability can often be triggered by three contributing factors. Damage caused by equipment used during cargo operations. The nature of the cargo itself, either causing corrosion to the hold structure or cargoes liable to shift or liquefy, leading to possible instability. And mistakes or deviations from the agreed plan during loading and deballasting, causing stress to the ship beyond its design limits. Let's look at each of these points in more detail, starting with damage caused by equipment used during cargo operations. Upon completion of discharge, the holds, hatch covers, and deck areas should always be inspected for any signs of damage. During discharge, the internal structures and coatings of the hold can be exposed to damage from grabs and from the hydraulic equipment often used to free and clear cargo residues. The hold bottom and tank top plating can also sustain damage. Typically, this appears in the form of denting and can be the result of high-impact drops or pours during the loading of heavier cargoes. On deck, the damage sustained from incidents during cargo operations can sometimes be more obvious. But the checking of coaming tops and smaller items, such as the correct functioning of hatch cover drainage channels, should not be overlooked. Any findings should always be reported and recorded. If damage is discovered which may affect the integrity of the hull, then the owners and the classification society should be notified, as this could affect the vessel's insurance cover. Such incidents could also prevent a vessel from sailing until an approved repair has been made. Stevedore damage may contribute to a weakening of the ship's structure, but the nature of the cargo can also have a detrimental effect. For this reason, the condition of coatings and welds in the hold should also be noted. Coatings are there to protect the steel from corrosion, either from the cargo itself or the environment. But many cargoes have corrosive or abrasive natures, which over time can damage this protection. The hatch covers, coamings, packing rubbers, and compression bars should always be examined for signs of corrosion or deterioration. However, other access points should also be inspected. In particular, the gaskets and securings fitted to manholes and inspection hatches should be checked to ensure they're structurally sound and weathertight. Where the effect of corrosion is more severe, any wastage will need to be checked against class regulations and specified diminution limits and repaired as necessary. Regular maintenance and the use of protective barrier coatings during the handling of certain cargoes will help to delay the long-term effects of corrosion. But while some cargoes can cause corrosion, others have characteristics that can result in an adverse effect on stability. For example, during loading, free-flowing cargoes such as grains and fertilizers will require careful attention when trimming to reduce the risk of instability. And grain cargoes in particular are subject to national and international legislation governing stability. But another less obvious risk affecting certain dry cargoes is liquefaction, causing the cargo to shift and the ship to become unstable. Liquefaction occurs if the moisture content of a cargo is too high. If stored in the open, for instance, a cargo could have become affected by recent weather conditions, such as rain or ice, potentially increasing the moisture content. Any commodity susceptible to this condition should have moisture content below the transportable moisture limit, or TML. This must be certified in the shipper's declaration, stating that the moisture content is within acceptable limits prior to loading. Stevedore damage and the nature of the cargo may contribute to either structural failure or instability, but a further potential risk to the integrity of the ship is the consequence of mistakes made during the loading process. The structure of a typical bulk carrier consists of a single-deck ship, fitted with topside tanks, a double bottom, hopper tanks, and side shells with vertical frames, corrugated bulkheads, and hatchways above. The holds are a series of large spaces separated by transverse bulkheads. Despite all this steelwork, the ship is not a rigid structure. In fact, for it to function effectively, there must be a degree of flexibility. However, overloading any one of the holds will cause excessive stress to the structure of the vessel. And if a cargo is poured into one end of a hold and piles up, the pressure acting on the transverse bulkhead will increase. Likewise, if cargo is unevenly distributed away from the vessel's center line, this will induce twisting and the subsequent warping of the hull structure, as well as placing stress on the transverse bulkheads. Therefore, the agreed loading sequence should be followed precisely, and cargo must always be stowed and trimmed appropriately within permissible limits. Whilst at sea, there are further forces that act upon the hull, which must also be considered. A ship has its own weight, made up of its structure, machinery, crew, stores and effects. Adding to this, by filling and emptying the cargo holds and ballast tanks, will generate additional shear forces and bending moments. Put simply, shear force is caused by two opposing forces acting against each other. There is a downward vertical force, which comes from the weight of the hull and cargo, and an opposing upward action, which is the buoyancy of the vessel. Shear forces occur when these forces are not in balance at every point along the length of the ship. A bending moment is a force that bends the vessel along its length. If weight is concentrated in the middle of the ship, bending of the structure will cause sagging. And if weight is concentrated at opposite ends of the ship, this will result in hogging. At sea, the ship is subjected to a continuous cycle of these varying forces and the changing wave pressure acting on the hull. If handled with care, the ship's structure is designed to withstand maximum permissible shear forces and bending moments. Shear force and bending moment calculations should always be prepared prior to any cargo handling or ballast water operation. The calculations must be accurate, because if the maximum permissible limits are exceeded, the ship could be at risk of structural failure. Handling a bulk carrier with care requires understanding and the full cooperation and expertise of both ship's crew and shore personnel. Both parties have a number of tools at their disposal, which assist with the correct loading, stowage, and discharge of cargo. Aboard ship, there should be an approved loading manual. This must give the ship's designed cargo loading conditions and distribution, as well as stating the maximum permissible shear force and bending moment limits. These limits are set for both harbour conditions, when the vessel is in port, and at sea conditions, which take into account the additional stresses of the ship moving in a seaway. The ship should also be equipped with a designated class-approved loading computer and appropriate software. As these systems vary, ship's officers must be familiar with and competent in the use of the equipment specific to the vessel. Ship's officers also need to be capable of producing an accurate loading or discharge plan. This must take into account ballast water management and stability, as well as the vessel's shear force and bending moments at each stage of any loading or discharge sequence. The calculations must observe the permissible harbour and at sea limits. And if plans deviate for whatever reason, the figures must be recalculated before acceptance.
It's 54% maximum.
Aboard some vessels, hull stress monitoring systems are fitted. These can provide ship's officers with real-time indications of the effects of shear force and bending moments, both at sea and in port. As they're often linked to the loading computer, they can highlight any deviations from the loading plan or the maximum permitted stress limits, allowing corrective action to be taken. There are also mandatory regulations and guidance in the form of 2 codebooks, which must be aboard every bulk carrier. The International Maritime Solid Bulk Cargoes Code, the IMSBC code, is designed to help ship's crew identify and correctly handle certain cargoes that could present a hazard, such as liquefaction or chemical reaction. The individual schedules not only describe the particular characteristics of these cargoes, they also provide general reference information relating to bulk densities, stowage factors, and trimming procedures. The Code of Practice for the Safe Loading and Unloading of Bulk Carriers, or Blue Code, is found in the supplement section of the IMSBC Code. The Blue Code provides guidance to ship's masters and terminal operators on the safe handling, loading, and unloading of solid bulk cargoes. Ashore, the Blue Manual supplements the Blue Code and provides further detailed guidance for terminal operators. By referring to these codes, and by understanding bulk carrier design and operating limits, both the ship's crew and shore personnel become key partners for the safety of the vessel. And as with any successful partnership, establishing good, clear communication early in the relationship is vital. Once a charter or commercial voyage has been fixed, it's important that the ship is provided with preliminary information about the prospective cargo and terminal, so that loading or unloading can be planned. If applicable, this information will be checked against the IMSBC code, so that ship's officers are fully aware of the properties or handling requirements of the intended cargo. The loading plan should also take into account the requirements of the IMSBC code, as this may have a bearing on stowage and segregation. But in all cases, the preliminary shipping information must be received in sufficient time to allow an accurate loading or discharge plan to be produced. Likewise, terminal staff will require information about the ship in order for them to put in place their own preparations for cargo handling. Therefore, a two-way information exchange between ship and shore must take place prior to arrival. This is to ensure the upcoming cargo operations are conducted safely and within the operational limits of both vessel and terminal. This information exchange should be laid out as specified by the Blue Code and must be clear, understood, and agreed by both parties. As early as possible, the master should provide the ship's ETA and particulars, details of any ballasting or deballasting requirements, along with a preliminary loading or discharge plan. This plan should be prepared in a form such as that laid out in Appendix 2 of the Blue Code. Amongst other items, it should include the quantity of cargo and the number and order in which holds are to be worked. The ship should also provide details of its mooring and gangway arrangements, as well as confirming that holds into which cargo is to be loaded are clean and free from previous cargo residues. For its part, the terminal should provide information such as the name and availability of the berth, the estimated times for berthing, the estimated times for the completion of loading or discharge, any characteristics of the cargo handling equipment, expected loading or unloading rates, and the name and contact details of the nominated terminal representative. Further factors to consider are the minimum depth of water alongside, berthing arrangements, and the availability of tugs. Any information given by the terminal relating to tides, the water depth at the approach and departure channels, as well as the water depth at the berth, must be accurate and complete to assist safe navigation. And the ship's arrival condition and maneuverability should always be considered. For example, a lightly ballasted ship can become vulnerable during navigation, as both rudder and propeller efficiencies are reduced, and the windage is increased. In these circumstances, the ship's ability to maneuver safely is reduced, particularly in high winds and strong currents. And with restricted vessel handling, the chances of navigational error, collision, or grounding increase. So it's vital that any proposed arrival or departure drafts, as well as any restrictions or time requirements relating to deballasting operations, are checked and agreed by both parties. And any conditions applied must always take into account the capabilities and safe working limits of both the ship and terminal.
We have 15.5 meters, okay?
Depth.
Yeah.
Once alongside, the terminal's nominated representative and the master, or chief officer, must conduct a meeting before starting cargo operations. At this point, the final cargo plan is discussed and approved, and a joint ship-shore checklist completed and countersigned by both parties. Amongst other items, this checklist will consider that an agreed system of communication along with designated liaison contacts aboard and ashore has been established. Any restrictions on taking bunkers have been put in place, and that the atmosphere is safe in the holds that may require access. Check, too, that the shipper has provided the information on the properties of the cargo, and that any testing certification relating to cargo characteristics is complete and accurate. Masters are ultimately responsible at all times for the safe loading and unloading of the ship. This includes controlling the safe and efficient synchronization of cargo operations and ballast water operations.
We have this information.
Both the terminal and ship should ensure the sequence of holds to be worked has been clearly identified and agreed.
1,000 per hour, maximum.
And the ship must ensure the cargo loading or discharge plan has been calculated for all stages of the operation, including at times of ballasting or deballasting. For this reason, it's imperative that the loading or discharge plan has been agreed and countersigned by both the ship and the terminal, and that communication and agreement is maintained at all times. If ship's officers are not satisfied with the cargo handling activity, or there is a sudden deviation from the agreed plan, the master should be informed immediately.
By that time we already need to sail out, so they're asking is that okay for us.
The master must stop the loading or discharge if the cargo distribution could adversely affect either the stability or the stresses on the ship's structure. Cargo distribution along the ship's length has a direct influence on the bending moments and shear forces. Evenly distributed cargo in all holds is usually adopted for low-density cargoes, such as coal and grain. This is called homogeneous loading. Large bulk carriers sometimes stow high-density cargoes, such as mineral ores, in every other hold. This is called alternate loading. When high-density cargoes are stowed in this manner, the weight of the cargo in each hold is approximately double that carried in a homogeneous load distribution. As a result, this requires a vessel to be strengthened and classified for this loading configuration. And under SOLAS, vessels over 150 meters and more than 10 years old are forbidden to use alternate loading unless certain conditions are met. Block loading is where cargo is loaded in two or more adjacent holds, with neighboring holds remaining empty. This method is often adopted when the ship is part loaded or carrying more than one commodity. It requires approved conditions as specified in the loading manual. And to avoid overstressing the hull structure, careful consideration should be given to the amount of cargo loaded in each hold and to the sailing draft. Regardless of loading method, at all times, the hull stresses should be kept below permissible limits. Loading rates and deballasting rates must be monitored throughout to ensure that the ship's structure is not overstressed and that shear force and bending moment limits are not exceeded. It's crucial, therefore, to monitor the ship's condition closely during cargo operations. Ship's personnel must carry out draft surveys at regular intervals to check the calculated ship's loading condition, the cargo weight, and its distribution. The recorded readings should be checked against the loading plan. This information, together with loading rates, ballast synchronization, stress and displacement calculations, all help to balance the forces acting on the hull. Officers on watch during cargo operations must ensure terminal staff follow the agreed plan. If there is any deviation for whatever reason, corrective action should be taken. If necessary, cargo operations should be stopped and the plan modified, ensuring that the stress and operational limits of the ship are not exceeded. For example, conveyor belts offer a very efficient method of loading, with rates varying between 1,000 and 16,000 tons per hour. And in some ports, rates can even go higher. This stretches the efficiency of the ship's ballast water system, making the synchronization between deballasting and loading difficult. In these circumstances, the ship and the terminal should agree that if deballasting becomes out of step with cargo operations, loading should be suspended until the deballasting operation has caught up. During both loading and discharge, mechanical equipment may also damage the ship's structure. Whilst discharging, the use of grabs or hydraulic excavators can cause damage to the hold structure or its protective coatings. And during loading, it is the terminal's responsibility to alert the master to any individual grab loads or pours that are large or heavy, where there could be the risk of a high-impact drop. These could potentially damage hopper sides and tank top structures, or stress the ship's hull. For this reason, particular care should be taken at the start of any loading operation into empty holds, especially when loading steel and scrap metal cargoes. Officers and crew members should be on the lookout for damage during cargo operations at all times. Manhole covers or gratings for bilge wells should be checked that they're present and intact. And any damage to the ship's structure caused by terminal handling equipment must be reported immediately. Guidance on damage reporting procedures is contained in the Blue Manual, Annex 3. But many companies will also have their own procedures. Loading equipment and conveyor designs vary. The time it takes to halt the operation must be taken into account to avoid overloading the ship. During the last stages of loading, the master should advise the terminal when final trimming has to begin in order to allow time for conveyor runoff. Trimming requires close supervision, and where applicable, it should be carried out in accordance with the requirements of the IMSBC code. For instance, some cargoes have a specific angle of repose. This is of significance with free-flowing, non-cohesive cargoes, liable to shift if not correctly distributed. In the case of discharge, the terminal representative should advise the master when unloading is considered as completed from each hold. And close supervision should be kept on the final stages of the unloading operation to ensure that all cargo has been discharged and holds cleaned as appropriate. On completion of any cargo operations, the master and terminal representative should agree in writing that the ship has been loaded or discharged in accordance with the plan, including any agreed variations. Any damage that has been occurred should also be recorded and noted by both parties. As terminals seek to maximize throughput and load vessels ever more quickly, the chances are that more mistakes will be made. The safety of a bulk carrier is in the hands of many individuals, both aboard ship and ashore. But the stresses and pressures are not just felt by the people involved. The very ship itself can also suffer from stress and fatigue. And just like people, bulk carriers need to be handled with care and respect.